Hey, what's up, everybody? This is Jonathan Coates, and in today's free AI training, I'm going to be talking about AutoCodeRover, which is another AI software engineer platform that I want to share with you. And this one looks to be the cream of the crop because compared to my other videos, such as AutoDev and the other open source models, this one seems to be the most popular at the moment. And I just want to explore and kind of give you an overview and just talk about it a little bit, as well as share their research paper and their Discord server where they have an entire community based around this. So it's open source. I have the open source model, and I say when they do come out, because when you go to their website here, autocoderover.dev, and you click on the products tab, there's nothing really for sale over here. They just give you their product design strategy as well as their development and engineering. But for the most part, and I'm going to have this in the video, all they have is just a demonstration and a link to their open source repository, which is this right here. So this is the actual model, and I just want to go over because there's two different stages. Now, the first stage is the context retrieval stage, and I want to explain that a little bit to you. And then after that, it goes through what's called the patch generation stage. So I'm going to read the overview here from their research paper, and I'll be sure to leave this in the description. It gives you a better understanding of the actual diagram itself. So if you just scroll down a bit, and again, I'll have this for you to access right below. And you can also see the same exact diagram on GitHub. But as you can see, there's two different stages here, the context retrieval and the patch generation. So you'll give it the problem statement. It'll collect the context by invoking the APIs. And then you have the API invocation, and you'll come up with results. Now, after you get those results, you'll have a context analysis. And whether or not it's sufficient determines whether it'll go through that loop again. If it is, then it goes into the next stage where it starts working on stuff like the bug. So if there's a bug at a certain location, where there's like a code at a buggy location, you'll tell it to write a patch, and then it goes to this patch generation phase, and then it'll get determined whether it can be applied or not. If not, then it'll go through that same exact process again until that loop actually corrects itself and you're able to get that final patch. So let's go ahead and talk about the overview real quick. We first described the overall workflow of AutoCodeRover is shown in figure 2. AutoCodeRover takes in as input a problem statement P of the issue to be resolved and a code base C of the corresponding software project. This problem statement P contains the title and description of the issue, as shown in section 3. From a problem statement written in natural language, AutoCodeRover analyzes the requirement from it and proceeds in two main stages, which are context retrieval and patch generation. In the context retrieval stage, AutoCodeRover employs an LLM agent to navigate through a potentially large code base C and extract the relevant code snippets relevant to P. The navigation is facilitated by a set of context retrieval APIs, which enables LLM to retrieve information about the project and actual code snippets. Once the context retrieval agent has gathered sufficient context about the issue, AutoCodeRover proceeds to the patch generation phase, as I was telling you earlier. In this stage, AutoCodeRover employs another LLM agent to extract more precise code snippets from the retrieved context and craft a patch based on the extracted code snippets. This patch generation agent is instructed to craft a patch in a specific format, and if the produced patch does not follow the format specifications or can't be applied to the original code base, the agent enters a retry loop, as I was saying earlier, and it terminates after a pre-configured number of attempts, which obviously you can configure that ahead of time. So let's go over the repository here. Now, this is the exact diagram that I was just explaining to you real quick. Now, if you go down a little bit further, they got the updates as well as some of the main features. I just want to share some of that with you. So those two stages that I was telling you about, context retrieval and patch generation. In context retrieval, the LLM is provided with code search APIs to navigate the code base and collect relevant context. And in the patch generation, the LLM tries to write a patch based on a retrieved context. Some of the highlights and unique features here include code search APIs are program structure aware. So instead of searching over files by plain string matching, AutoCodeRover searches for relevant code context, methods, and classes in the abstract syntax tree. And then when a test suite is available, AutoCodeRover can take advantage of test cases to achieve an even higher repair rate by performing statistical fault localization. So they do have different comparisons here, and they go over that. I'll let you reference this in the description, and I'm also going to include this demonstration right in the video. So this is from the actual owner himself, the person who created this, two different use cases. And right here at the very bottom of the GitHub repository, just like in my Auto-GPT and AutoGen video, originally with AutoGen, before you were able to use a web API, I showed you how to install it locally. It's a very similar type deal. You can use Visual Studio, Python, etc. and they go through the steps of actually installing it here. It's very detailed step by. They even give you the code here to just copy it and put it in there, so you don't have to type it, etc. And all you gotta do is go through this and you have it up and running in no time. Now, when it comes to Llama 3 models, before using, you want to install Ollama and download the corresponding models with Ollama. You can run Ollama server on the host machine and ACR in its container. ACR will attempt to communicate to the Ollama server on host. If you're set up as Ollama in host plus ACR in its container, then they recommend Docker Desktop on the host in addition to Docker Engine. Docker Desktop contains Docker Engine and also has a virtual machine, which makes it easier to access the host ports from within a container. With Docker Desktop, this setup works for those folks that want to use the Llama 3 models. They have instructions at the very bottom, and you can use other LLMs other than just the main typical mainstream ones out. And I'm gonna go directly to that section. He actually talks about that. So again, AutoCodeRover is a fully automated approach for resolving GitHub issues, bug fixing, and feature addition, where LLMs are combined with analysis and debugging capabilities to prioritize patch locations, ultimately leading to a patch. And their update on June 20th here says that AutoCodeRover can now resolve 30.67% of issues in SWE bench-like. AutoCodeRover achieved this efficiency while being economical. Each task costs less than 0.7 cents and is completed within 7 minutes. And be sure to check out their Discord too, because they have an issues tab. They do have an entire community here where folks can come and post their issues. If you have anything or challenges that you run into and you want to get direct answers from the community, I definitely recommend this Discord. And then as well as this website, just kind of give you more overview and information. I'll have this in the description as well. But I'm going to go ahead and link this to these videos now. Before I transition over into the actual demonstration here, I just wanted to talk about using different models. AutoCodeRover works with different foundation models. You can set the foundation model to be used with this command line here. Here's the current list of supported models. You got OpenAI's GPT series, Anthropic's Claude series, as well as Meta, AWS, Grok, and they have instructions and just some disclaimers, as I was saying earlier with Llama. So rest assured, you don't only have to just rely on GPT-4 or even Claude, Claude is actually my favorite right now. So I'm going to go ahead and transition over into this video here, just to kind of give you a use case straight from the horse's mouth himself, so that you can have a clear understanding and a better visual of how this works. So with that said, the video should start right now.
Hello everyone. I'm Haifeng Ruan, PhD student from National University of Singapore. In the second video about AutoCodeRover, our new technique for autonomous program improvement, I'm going to talk about how AutoCodeRover can solve even more tasks by taking advantage of test cases in the projects. In the first video, we have discussed that AutoCodeRover works in 2 stages, context retrieval and patch generation. The input to the workflow is the issue statement and the project source code, and no test cases are needed in this process. However, if test cases are made available to AutoCodeRover, AutoCodeRover would be able to take advantage of them in both stages. In the first stage, AutoCodeRover would additionally perform spectrum-based photo localization, and in the second stage, AutoCodeRover would additionally perform patch validation. Let us get into more details about the 2 enhancements. The first enhancement is spectrum-based photo localization, also known as SBFL. What does SBFL do? Basically, SBFL executes test cases and records their execution traces. From the execution traces, SBFL would calculate a suspiciousness score for every method, indicating the likelihood that the bug is located in the methods. We would not get into details about the calculation, but the general idea of SBFL is that a method is more suspicious if it appears in the execution traces of more failing test cases, and if it appears in the execution traces of fewer passing test cases. The suspiciousness scores calculated by SBFL provide additional clues for the context retrieval agent so that it is more likely to find the buggy locations. Let us see a real-world example of how SBFL helps. So this is an issue taken from the Django project talking about incorrect relation handling. In this issue description, we can see a lot of class names and variable names, but none of them is the root cause of the issue. Instead, they are just distractions. On the other hand, the root cause of the issue, which is the relation handling, is quite inconspicuous in its description. As a result, it would be quite difficult for the context retrieval agent to know where to search. For example, in our experiment, the context retrieval agent searched in 3 irrelevant places. As a result, AutoCodeRover could not write a correct patch for this issue. So what do? SBFL would come to the rescue. With SBFL, we can list the most suspicious methods. And in fact, the third most suspicious method is actually the buggy method. We also noted that there is the word related in the name of the method, which coincides with the relation keyword that appeared in the issue description. With these 2 pieces of information, the context retrieval agent actually knew to search in the actual buggy method. As a result, AutoCodeRover could write a correct patch with the help of SBFL, and this patch is equivalent to the patch written by the developer. The second enhancement made in the patch generation stage is patch validation. In the original workflow, the workflow stops as soon as we find a patch that can be syntactically applied to the original program. With test cases, we can do better. Whenever we generate a patch, we can make the patched program run all the test cases to see if the patch is a correct patch. If the patch is not correct, then we can take another try. In total, we allow AutoCodeRover to make at most 3 attempts, and this has increased the chance that AutoCodeRover writes the correct patch. We have calculated the effect of the 2 enhancements in our experiment. So the original AutoCodeRover could solve 16% of the SWE bench light tasks in a single run. With validation, we can solve another 1% of these tasks. And with SBFL, we see a relatively significant improvement, and we could solve more than 20% of the bugs. Again, more information can be found in the homepage of our projects, and issues and discussions are welcome. Thank you. Hello everyone, I'm Haifeng Ruan, a PhD student from National University of Singapore. I'm happy to introduce AutoCodeRover, our new technique for autonomous program improvement. This work is done together with Yuntong Zhang, Zhiyu Fan, and Abhijit Chaudhary. So why have we made AutoCodeRover? In recent years, software engineering has become more and more automated. For example, we can do test generation automatically with symbolic execution, we can do automated program repair, and we can do automatic code generation with various LLMs. In this case, one would wonder, can software maintenance be automated and autonomous as well? With AutoCodeRover, our answer is yes. So what does AutoCodeRover do? In a word, AutoCodeRover takes in a GitHub issue and outputs a patch that resolves the issue. It can do both bug fixes and feature additions. AutoCodeRover works in 2 stages. Given an issue statement, AutoCodeRover would first rover in the code base and collect relevant context to find out the buggy locations. In the second stage, AutoCodeRover tries to generate patches at the buggy locations to actually resolve the issue. Let us get into more details about the two stages. In the first stage, AutoCodeRover has a set of code search APIs. AutoCodeRover would interact with an LLM agent to decide what APIs to call and with what arguments. The decided API calls would then be executed locally by AutoCodeRover to retrieve the relevant code snippets, and the code snippets would be returned to the agent for further analysis. The code search can go on for multiple rounds until the agent decides that enough context has been collected to pinpoint the buggy location. Let us see a real-world example from the Django project. So here is the issue statement talking about a missing piece of error information in the code. AutoCodeRover would provide a set of 6 search APIs, such as search class, search method in file, and search method in class. AutoCodeRover would prompt the agent to analyze the issue and select necessary API calls. So what does the agent select? In this case, the agent selects 2 API calls for searching classes and another 2 API calls for searching for a method. So these 4 API calls would be executed locally by AutoCodeRover. For example, for this class, we have retrieved all its member variables as well as all its member functions. This context would be analyzed further by the agent. Here is the analysis. As we can see, this context has already provided the agent with some insights into the root cause and the resolution of the issue. We have another round of code search to do before we have enough context to decide on the buggy location. So here is the buggy method, which is the toPython method in the method choice field class. With this buggy location, we would then go into the second stage of the workflow. In the second stage, AutoCodeRover would first retrieve the code at the buggy location, then prompt another LLM agent to write a patch. If it turns out that the patch cannot be applied to the program, AutoCodeRover would prompt the agent to write another patch. Finally, we would get a patch that can be applied to the program. Back to this example, we would first retrieve the code at this buggy toPython method. And then we would prompt the agent to write a patch in such a format. So here is the agent written patch. It turns out that the patch can be applied to the program, and here is the patch that we have extracted. It turns out that this patch can be applied to the program and it can correctly resolve the issue. So that's the end of the workflow. This is just one of many issues that can be solved by our AutoCodeRover. For more information, you can go to our project homepage, and you are also welcome to contact us by email to have any discussion. Thank you for watching.
All right, I hope you enjoyed that. As I said, he can explain it a lot better than I can, and it's pretty exciting if you see just how this is all set up and it works. So you should have seen both of these videos just now. I'll have this in the description. You want to see it again, or you can just rewind this. And be sure to take a look at the tools and the resources below. I'll have everything that I included in this training, as well as the pinned comment below by the Affiliate Marketing Samurai. I'll also have a link to my other videos on automated AI software engineers. My other one, I believe, was called AutoDev. It was really interesting. It was an open source version of Devin. All right. Just keep in mind, this isn't an all-in-one solution. It can't do absolutely everything for you. You're going to still need a human there to make sure that it's working correctly in the way that you intended it to. But so long as that you're following the instructions and sticking to the community and asking questions and just working along and working through those challenges, you should be up and running. So that's pretty much it. I hope you enjoyed. If you like this kind of content, then I definitely recommend that you subscribe to the channel. I talk about everything when it comes to generating traffic and increasing sales for your business. And also be sure to take a look at the AI checklist right in the description. It's completely free. All you gotta do is just put your name and your email address in and it gets sent right to your inbox. And it's going to help you to boost efficiency and creativity. All right. So with that said, I hope you enjoy. I'll see you in the next video. See you then.